this is a system that's been installed for a while, which isn't generating because it's got low insulation resistance problems. And the problem is the whole roof is, I mean, this is a relatively good bit, it's only a centimetre or two deep in water, but then you just get connectors sat in it and they get water in, and my guess is if I was to take that apart it would be sodden. But I need to work out which string the problems are and just cable tie all of this lot. This all should be tied up underneath the panels here, like this one is, but yeah, cable ties have failed in. I mean, you can see that one sat on the water, those two over there would be sat on the floor if, you know, it's just all over the shop. Okay, so a quick update then. None of the strings have got particularly good insulation resistance, but one of them is particularly bad at 0.15 mega ohms. So that string is now disconnected. The other ones are now connected and it's generating, which means I can check that there is current on each string. So that's good. And what that means is then I can walk around the roof with the clamp and find out which string is the dodgy one. So catch you back in a bit once I've worked out where the fault is. If I had to guess what the problem was when I first came onto this roof, it was that. Obviously it needs testing, but I'd be amazed if it wasn't that. It's definitely on this string and that's not right. I forgot to include the correct step in working out where the fault actually is. The first thing you do is to drop your expensive meter into a puddle. That's a very important step. Then you clamp it onto something so it doesn't fall into a puddle again. There we go. Then you measure the voltage of the string. Here we have 560. Then you measure volts to ground from one way, 430. And then you measure volts to ground the other way, which is 34. And in principle, if you add those two numbers together, you get back up to 560. And as you can see, that hasn't happened, but it tells us that the fault is 1 to 2 panels in from the end from one direction. Right, so I've just repeated the tests at 1000 volts. You can see this has got a lot better, but that's still pretty terrible, which makes me think there's probably a fault somewhere else as well. So that's probably helped, but that's not the full story. And we're back to the voltage tests, and if you're wondering why I've got the bleeds plugged in wrong, it's because the cretin that made these test adapters did them wrong, and yes, that was me. So we've now got 440 one side, and 32 the other, which still suggests actually the fault's in the same place. So that's fun. Okay, final connector, well, second, but final that I'm going to change, has now been changed. Insulation resistance is back up to a sensible value. It's now raining quite a bit more than it was earlier, so I'm going to pack up, go around the roof with a packet of cable ties, tie every single connection up out of the water, button this all back up again, and job's good. Lots of cable ties being used. I'm halfway through doing that job, but for some reason the installers on this one used SY and they've left a bit lying around. Who knows? Was not our team doing that. Anyway, final sanity check before we go home. One, two, where are you? 3, oh come on, and 4. So that's all good stuff. Not that you can see this screen, but Oh yeah, you sort of can. So 0.8 of an amp on string 1, 400 and some odd volts on string 2. There we go. So, oh, that's interesting. Why is that now only reading 0.3? Oh no, that's fine. That's fine. That's both of them. I thought this little bit of SY was left over from the solar installation, but it's not. It's permanent.